Right, so we're going to continue with another OR example in this next problem. Again, we're going to use the idea of whether or not events are mutually exclusive to help us with this problem. So we're told to roll a fair six-sided die, decide if events are mutually exclusive, then find the probabilities below. Right, so for a die is rolled and an even number is on top, a die is rolled and a 5 is on top. Right, so to start with, these are mutually exclusive. Right, these are mutually exclusive. It is impossible to be both. Because 5 is not even. All right, so now we're going to think about our different scenarios. So even numbers. Our even numbers on a die are 2, 4, and 6. And then we have exactly one number 5 on a die. So since our events are mutually exclusive, we can add P of E, probability that the roll is even, plus the probability that a 5 was rolled. Probability that the roll was even, 3 out of 6. The probability that the roll was a 5, 1 out of 6, which gives us 4 out of 6, which reduces to 2/3, or as a decimal, 0.66 repeating, or as a percent, 66.7%. Okay. So that's one way that we can work that out. There was no need to subtract anything because our events were not mutually exclusive. Another way we could write this out is we could write just 3 plus 1 over 6, right, which gives us the same result if we just want to use our numerators instead of our individual probabilities. Either way works. All right, so let's go through another example. All right. A die is rolled and an even number is on top. A die is rolled and a number greater than 4 is on top. These are not mutually exclusive. It is possible to be even and greater than 4. All right, so now I'm going to do the same thing I did in the previous example is start listing things out. So our even numbers, 2, 4, 6. Numbers greater than 4. All right, just 5 and 6 because it's greater than, not greater than or equal to. Both, right, is just the number 6. All right, so now in this case, since we are not mutually exclusive, we're going to write the probability that it's even plus the probability that we are greater than 4 minus the probability of even and greater than 4. So probability of even, 3 out of 6. Excuse me. Greater than 4, 2 out of 6, since we had 2 numbers listed there, minus both, which is 1 out of 6. 3 plus 2 is 5, minus 1 gives us 4 out of 6. So it actually simplifies to the same thing that we got in our previous example, just because we're using small numbers. Just pure coincidence there. Again, when we're writing out our kind of different pieces, we have a couple of different ways that we can write it. If we don't want to write it as all different fractions, again, we can write all of our numerators together. We have 3 numbers that are even, 2 numbers that are greater than 4, minus 1 number that is both, and we end up dividing that all by 6. Either way, we get the same thing. Okay, so as you're working through OR probability problems in section 5.2, what you want to do is you want to pay attention to whether or not the events are mutually exclusive.